Hey guys, welcome to the solutions for the quadrilaterals test, and hope this is helpful. Let me know if you have any questions in person that you want to meet with me, and then we can definitely go over those. But figured I'd get you guys the video, make your corrections, really tell me what you did wrong on the piece of paper, and then I'll give you half a point back for every problem you missed. So let's take a look at your quadrilaterals test. All right. So the first three, we were given that, and I have just the solutions written down. I just want to talk about them and highlight some stuff here. So the first three, we have that this angle right here is angle QRS is 110. We also know that side PQ is 17.5. And we also know that ST is 18. Okay. So first thing wants to know is RS. Well, RS is 17.5 because it is a parallelogram, and parallelograms opposite sides are congruent. So it's the same as PQ. So those are the same. So RS is 17.5. QT is 18. Now, why is QT 18? Because on a parallelogram, the diagonals bisect each other. So if this chunk right here is 18, then the other chunk over here also has to be 18, QT. So that has to be 18 also. And the last thing is, number 4. What's the measure of angle PQR? Well, where is angle PQR? This angle right here. Now, think about this. We've talked about this before. These are same side interior angles. We have two parallel lines. Same side interior angles are always supplementary. They always add up to 180. And we're going to see that in the final proof on this. So they're same side interior angles of these two parallel lines. Since it's a parallelogram, same side interiors are always supplementary. So 180 minus 110 is 70. And then the last one is SPQ. SPQ is this angle right here. It is opposite of the given angle QRS. And so opposite angles on a parallelogram are equal. So that's why that is 110 also. So this is 110 right here. Okay. Hopefully that was helpful on those first few. If you have any questions, just come see me if you don't see what's happening in this video. Okay. All right. Now the next thing is, this thing is a parallelogram. We're going to find each measure. Well, so you got two. Let me get rid of my face here. We don't need to see my face anymore. So guys, there's two things here. We want to find X, and then we want to find Y, and then we want to find the measures. Okay, so the first one we want to find is angle X. Now, since this is a parallelogram, opposite angles of a parallelogram are congruent. So all I did is just put these two equations equal to each other, okay? And then what did I do here? I subtracted 9x off both sides, so I get negative 5 equals x minus 19. And then I added 19 to both sides, and I got x equals 14. And then did I find the measure of angle B? Well, I just went over there and said, instead of saying an X, I put in a 14. 9 times 14 minus 5 is, what do we get? 121, right? All right. And then the next one is we wanted to find Y. Now, Y, opposite sides of parallelograms are congruent. If it's a parallelogram, their opposite sides are congruent, so their measures are equal. So I put these two equations equal to each other. I subtracted a Y from both sides, and I added a 1 to get rid of that 1, and I divided by 2 and got Y equals 8. And then I just plugged that number into the equation for just one of the equations. I used 3y minus 1. 3 times 8 minus 1 is 23. And that's how I got that. All right. And just make your corrections as you go along. Okay. So this is saying that this is a rhombus. Find the measure of each thing. Okay. Oh, we want to find the measure. So let's see here. First thing we want to find is x, right? So since it is a rhombus, opposite sides, all sides are congruent on a rhombus. So Remember, the definition of a rhombus is all sides. It's a parallelogram with all sides congruent. So I just know that 4x plus 15 has to equal 7x plus 2. Do a little algebra here. What did I do here? I subtracted 4x's from both sides and got 15 equals 3x plus 2. And then, so I subtracted the 4x from both sides. And then I got 15 equals 3x plus 2. Then I subtracted a 2 from both sides and got 13 equals 3x. I divided both sides by 3 and got approximately 4.3. Now, I want to go ahead and put that equation into, I think I used this guy right here. And so I said 7 times 4.3 plus 2. And I said you guys could use a calculator on this, is approximately 32.1. So there's a point and there's a point for 2 points. Okay. Now, this next problem, I do say that it is a parallelogram. Okay. All right. And that's important. And so it's a parallelogram. So that's important. So we can say, and then we go through on number 8, they say EF is congruent to GH and FG is congruent to HE and FH is congruent to GE. Is this a rectangle? And the answer to that is yes, because the diagonals are equal. This guy right here, it's a parallelogram, okay? And we know it's a parallelogram because the opposite sides are congruent, okay? This part right here is telling you that the opposite sides are congruent. And this part right here is telling you that its diagonals are congruent. So if it's telling you it's a parallelogram because the opposite sides are congruent, and it's telling you the diagonals are congruent. So parallelograms with diagonals congruent means rectangle. Okay, so the answer to number 8 is yes. All right, the answer to number 9 is no, because if you got FEH, well, FEH or FEH, G is 45 degrees and FEG is 50 degrees. You add those up, you get 95 and not 90. And remember, rectangles always have to have 90-degree angles. So the answer to that would be no. All right. In a kite, we've got all this good stuff. Now, the key, so let's see what we have here. So we know that BAE is 28. So we put the 28 right there. BCE is 57, which is right here. And we want to find each. What is the measure of ABE? ABE. Well, to find that measure, we have to know one thing. Kites' diagonals are perpendicular. Just like rhombuses, and we've talked about this, kites have perpendicular diagonals. And that's very important. You know that. So now you can say that this angle right here, this angle E is a right angle. So we can write this equation and figure out what angle X is. ABE. We can figure out that angle X by simply just adding up and setting it equal to 180. So X plus 28 plus the 90, because the diagonals are congruent, the diagonals are perpendicular, is 180. And then I just combine like terms. 28 plus 90 is 118. Subtract 118 from both sides, and I get 64 degrees. So I get 60. What was the answer on that? Sorry about that. This should be 62. I make my math. I did my math wrong here. 62 degrees. So this should be 62 degrees. All right. All right. So that's 1. So you get 1 point for that one right there. Okay. The next one we want to get is CBE. Measure of CBE. Well, again, we know that this is 90 here again. That angle E is 90. We know we have a given 57. We want to find Y. I'm going to call that angle Y, and that equals 180. Doing the math, we add 57 and 90 to get 147. Subtract 147 for both sides, and we get 33. So that one is 33 degrees right there. That's 33 degrees. We know that this angle is 62 degrees, right? Okay, what's the next angle we want to find? ABC, angle ABC. Well, that we just add those up, right? We're just adding 62 and 33. We're just adding these two angles up right here, and we're getting 95 degrees. And then we want to know the measure of measure of ADC. ADC is down here. And we know, ladies and gentlemen, that those two angles are, remember, a kite always has one pair of congruent opposite sides, and B and D are the congruent opposite sides, so they are equal. So these two angles are congruent. So we already know that this angle right here is 95 degrees. So this angle right here has to be 95 degrees. Okay? Hopefully that makes sense. Next problem. All right, so now it's telling us what would make this an isosceles trapezoid. Okay, and so what do we know about isosceles trapezoids? Isosceles trapezoids have congruent diagonals. Diagonals of isosceles trapezoids are congruent. So we would just say in this case that AC has to be equal to BD. So we have to figure out the y value that is going to set those two equal to each other. So we just put 3x plus 12 equals 27 minus 2y. What do we do here? We added 2y to both sides for some algebra here. That gives us 5y plus 12 equals 27. And then we subtracted 12 from both sides here, which gave us 15. 5y equals 15. We divide by 5, and we get 3. Okay. All right. The next problem is mid-segment. We want to find the mid-segment. We know that this is a mid-segment because we have two. It's a line that intersects the midpoint of two opposite sides on a quadrilateral or a trapezoid. Sorry. So we want to find its mid-segment. So the mid-segment is always just half the two bases, or the average of the two bases. So we add the two bases up. So one base is 13.3. The other base is 17.9. We add those up and get 31.2. Take half of that and we get 15.6 for x, y. All right, next one. Okay, so this one's a little more challenging because it is also a mid-segment. So we know the mid-segment right here is equal to 1/2 the addition of the two bases. So we're going to add this base here and this base here, right there. So we have to add those two bases up, divide them by 2, and that's going to equal the mid-segment. Okay, so I do a little math over here. It looks like I have y plus 3y is 4y, and then 3 minus 7 is -4. Okay, and then I do the distributive property. I take that 1/2 and I distribute it through, and I get 1/2 of 4 is 2, and 1/2 of 4 is 2 also. So I get y plus 6 equals 2y minus 2. Let's see here, I subtract a y from both sides, and I get 6 equals y minus 2, and then I add a 2 to both sides, and I get x equals 8. So the key to this one was this formula, being able to write this guy right here. That's the key, is being able to know that the mid-segment is always equal to 1/2 the sum of the two bases. These two bases added up and divided by 2 are always going to equal the mid-segment. Okay? All right, moving on. Okay, show that this is a parallelogram. And I wanted it by definition, okay? So the definition of a parallelogram are opposite sides need to have the same slope. Because if on the coordinate plane, we know two lines are parallel if they have equal slopes. So we have to show that the blue lines have the same slope and the yellow lines have the same slope. So if we want to look at BC and AD, the blue lines, we can see that if we do rise over run, you go down 2, right 1. Okay, see that? You go down 2, right 1, and you get a slope of -2 over 1. You also get a slope of -2 over 1 on AD. So they have the same slope. So those two opposite sides are parallel. Now, on the other red sides, we go up. I don't know. I think it was I can't remember. It was 6 and 4, I believe. You go up 6 and over 4, and you reduce it to get 3 over 2. And the same thing with the other one. You go up 6 and over 4, and that reduces to 3 over 2. So those two have the same slope. So therefore, this is a parallelogram, because by definition, a parallelogram has opposite sides parallel. That was the key. So we had to show that the yellow lines are parallel and the blue lines are parallel. Okay, show that this is a rectangle. Well, what I did to show it was a rectangle is I looked at these slopes right here. I looked at, let's say, a slope at each corner. I'm going to say, well, what are the slopes of those two lines where they meet? Well, if I want to look at DG, the slope of DG is 3 over 2, okay? If I want to find the slope of GF, that slope was -2 over 3. Now, what do I notice about those two slopes? Those are opposite inverses of each other. Opposite inverses. Whenever you have opposite inverses, you know you have perpendicular lines. And if you have perpendicular lines at every single corner, that's going to happen at every single corner, then you know that every one of these are perpendicular, which means they're all right angles, which means it's a rectangle, okay? So if all the angles are right angles, it is a rectangle. So that's how I did that. You could also show that the diagonals are congruent by showing that DF is congruent to GE, if you wanted to do that. All right. Okay. So I think the big thing there is to show that the angles are perpendicular. All right. So the next one, there's a couple things you can do. Let me just show you where I put this on graph paper. I graph this points right here. Okay. So I graph the points, and I got something that looked very rhombus-ish looking. Doesn't look very squarish because the angles don't look like they're right. It doesn't look rectanglish, but it looks very rhombish looking. So there's a couple things I could do to show that. First of all, if I go back here, it does tell me what it is a parallelogram. So to show it's a rhombus, I could show that could do a couple things. I could show that the diagonals are perpendicular, because on a rhombus, the diagonals are perpendicular. So I could go through and find the slope of KM, and I could find the slope of JL. Well, when I'm talking about KM, I'm talking about KM right here, this diagonal, and this diagonal right here, this JL. And what I can do is I can find those two slopes, and if those slopes are perpendicular to each other, then I know it's a rhombus, because a rhombus has perpendicular diagonals. Now, so do kites, but it already told me it was a parallelogram. So it couldn't be a kite because it's already given that it's a parallelogram. So that's one way you could say that it's a rhombus. It could have perpendicular diagonals. You could also just go through and figure out all the lengths of all the sides. And what I did is I just went through and I figured out the length of two adjacent sides, and they're all going to be 5 square roots of 2 when you do the distance formula. And that's by definition, a rhombus is a parallelogram with 4 congruent sides. Okay, so you could either do the diagonal theorem up here, or you can do show that all the sides are the same, which I found them to be 5 square roots of 2. Okay. All right. We did that. Okay, let's look at the proof really quick. Okay, so we have this proof, and what I did is I broke this rectangle up into two congruent triangles. And the two congruent triangles that I want to look at are the crisscrossing ones. I want to look at this one right here, and I pulled them apart. And I want to look at this one right here, the ones that are crisscrossing. Now, there are other ways to do this proof. Okay, I want to let you know there are other ways to do this proof, but this is kind of the way I kind of thought of it. So I did give credit for other ways, but here's an official way. If you're completely stumped on this proof, I'll show you how to do it. Okay, so the first thing is we have a parallelogram, and that's given. Now you got to just remember all the good stuff about parallelograms. We also know that EG is congruent to FH. So EG, so where is EG? EG is congruent to FH. Now, a lot of you said, well, that means that it has to be a parallelogram. I mean, it has to be a rectangle. Well, I think in the notes that I said, I do want you to prove that the triangles are congruent. So if you just said by definition, I gave you 1 point, that's correct. But I did specifically say I wanted you guys to have, I wanted you guys to show that the triangles are congruent and do it that way. All right, so that's given. And then this is given. Okay, so now we can say that EF is congruent to GHG. So we can say that these two sides are congruent to each other because it's a parallelogram, and parallelograms have congruent sides. So what I did is on my triangles I pulled apart, I just put those in there also. Okay, see what I'm doing there? All right, and then I got that. So given sides are parallel, that. Okay, so EH is congruent to EH. Now, if you look at both of these triangles right here, they're both sharing this side EH. Okay, that's the reflexive side. So I went through and said, hey, EH is congruent to EH because it's reflexive. All right, so now what I can say is that these two triangles are congruent because of SSS, side, side, side. Now, after that, I can say that angle FEH is congruent to angle GHE. And I can say that because of CPCTC. So FEH, this angle right here, is congruent to GHE. So I can say that those two angles are congruent to each other because of CPCTC. Now, here's where it gets a little interesting. Okay, so now I can say that FEH and GHE are supplementary because they're the same side interior angles. Now, what do I mean by that? So FEH, so FEH, this angle right here, and GHE, these two angles here are supplementary because this is a parallelogram and same side interior angles are supplementary. So this angle right here and this angle right here are supplementary, but they're also congruent to each other. Okay, so if angles are congruent and supplementary, then they must be right angles. And if they're right angles, that means all the other ones have to be right angles too because it's a parallelogram. And so opposite angles are congruent. And therefore, ladies and gentlemen, all the angles are right. And so it's a rectangle. Okay? So the key, in my opinion, is get it. So here's where I gave the points. I wanted the reflexive property in there. I wanted SSS. I wanted CPCTC. And then I wanted to see if you could come up with something like this. Okay? In theory, that if you know the angles are congruent and supplementary, then they are right angles, which means it's a rectangle. Okay, so that's kind of my gist there. If you have any questions, you want to talk about that just in person, or if you feel like I'd missed you on a point there or not, just let me know and we can talk about it. But besides that, we are good to go. So I'm going to go ahead and stop sharing and post this video and get those corrections to me ASAP, and I'll get you those points into the computer. See you later. Bye.